Electric lighting provides illumination for overall brightness of an area, for performing tasks, and for providing safe pathways for indoor and outdoor applications. Understanding the basic terminology, environment, and lamp type is essential for helping our customers specify the right lighting solution. First, let's begin with three fundamental terms: light, lamp, and luminaire. The lamp is the light source, including the inner parts and the outer bulb or tube. The term luminaire is the technical term for what most people call a light fixture. This complete lighting unit is used to produce, control, and distribute light. A luminaire would consist of one or more lamps, mechanical components that hold the lamps and position them for directional illumination, an optical system that distributes the light, and the socket that provides the means of electrical connection. Luminaires are designed around the most common lamps available. Their size, materials, thermal properties, and photometric design depend on the type of lamps being used. In almost all fixtures, light is projected within multiple directions. To efficiently provide illumination to an application, the fixture will require components that can produce, control, and distribute light. There are four commonly used components to control light: reflectors, refractors, diffusers, and louvers. A reflector is the process of redirection of light from a surface. Refraction is the bending of light waves. Diffusing is the method of spreading or scattering the light wave into multiple directions. And louvers is the method utilizing slatted material to direct or control the spread of light. There are several terms that help define important characteristics of lighting: wattage, voltage, and lamp life. Lamp wattage is a measurement of electrical power consumed by a lamp during operation. Lamp voltage is the measurement of potential energy between two reference points. Lamp life is the rating of operating hours at which 50% of the tested lamps have failed. The standard incandescent has a life expectancy of about 750 to 1200 hours. Fluorescent lamps are rated up to 36,000 hours. Nevertheless, some high-intensity discharge lamps are rated for up to 40,000 hours, while LED technology has increased the operating hours to as much as 80,000. Now that we understand the types of lamps and the expected operating hours, we will now review the basic concepts of light measurement. A lamp's illumination is measurable in terms of the light it emits and the amount of light that reaches a surface. The basic units of measuring light are the candela, the lumen, and the foot candle. The candela is a unit of intensity of light at the source. For example, the flame of a typical wax candle has a luminous intensity of 1 candela. The lumen is a unit of measurement for light output by a light source. 1 lumen is the amount of light striking a 1 square foot area at a distance of 1 foot away. And the foot candle is a measure of illuminance or density of light falling on a surface. 1 foot candle equals 1 lumen per square foot. Now let's examine color output. The color output from a light source is commonly described in two ways. One is by color temperature, and the other is through color rendering index. Both of these are key considerations in applications where accuracy of color is important. Color temperature is the measurement indicating the warmth or coolness of the color appearance of the lamp, expressed in Kelvin. Here's how it works. The higher the color temperature, the cooler or more blue-white the appearance. The lower the temperature, the more warmer the appearance and the yellower the light. Normally, lamps rated at below 3200 K are warm sources, while lamps rated above 4000 K are white sources. The color rendering index, or CRI, is the measurement of the ability of light sources to render colors true to life on a scale of 1 to 100. The higher the CRI, the richer the colors. Now, we will look closer at the four broad categories of electrical lamps: incandescent, fluorescent, high-intensity discharge, or HIDs, and light-emitting diodes, or LEDs. Incandescent lamps are the oldest, least expensive, and least efficient electrical light sources. The glass envelope or bulb of an incandescent lamp gives its shape and contains the inert gas in the metallic filament. Other parts include the arbor, the stem, and the base, through which the electrical connection is made. A standard incandescent lamp produces light when the filament is heated to an extreme temperature by the flow of electricity. The metal gets so hot that it glows white, emitting visible light. The process is called incandescence. The long straight tube and base of many fluorescent lamps is as familiar to most of us as the standard A-shaped incandescent lamp and base. However, fluorescent lamps come in a variety of shapes, including folded tubular and spiral, which is the shape of many compact fluorescents, commonly known as CFLs. Regardless of the shape, fluorescent lamps produce light very differently than incandescent lamps. They rely on a ballast to start and continue operating. The sealed glass tube is coated with a thin layer of phosphorus and contains a small amount of mercury and an inert gas, such as argon, under very low pressure. There are electrodes at both ends of the tube. When high voltage is applied to the electrodes, an arc passes between them, ionizing the mercury in the tube and producing the ultraviolet energy, which in turn excites the phosphorus and transforms the UV to visible light. All fluorescent lamps require a ballast to control the flow of current to the lamp. This aids in starting the lamp and for continued operation. Now let's look at three methods used to start the flow of current through the tube of the fluorescent lamp. They are preheat, instant start, and rapid start. A preheat circuit features a separate switch or push button. This preheats the filament before the lamp is turned on. An instant start circuit relies on a ballast that provides a voltage high enough to start the lamp without any need for preheating the filament. A rapid start circuit also does not require a separate starter. Instead, it uses a continuous filament heated to both start and maintain the lamp's light output. Next, we'll cover high-intensity discharge lamps, also called HIDs. Like fluorescents, HIDs also feature electrodes and require a ballast to step up the voltage to maintain operation. In an HID, the electrodes are inside an arc tube within a bulb. The tube is filled with gas and with metals. The gas helps start the lamp. However, the metals, when heated to the point of evaporation, light is produced. Because an HID lamp takes anywhere from 3 to 15 minutes to achieve full brightness, they're not used for application where lights are frequently turned off or on. There are three major types of HID lamps. They are mercury vapor, which are no longer being made, high-pressure sodium, and metal halide. The lamps all have different combinations of gases within their tubes. The traditional version of high-pressure sodium lamps produce yellowish light. Some versions are now capable of producing whiter light. In contrast, metal halide HIDs deliver white, natural light. A light-emitting diode, or LED, is a semiconductor device that creates light using solid-state electronics. A diode is composed of a layer of electron-rich material separated by a layer of electron-deficient material, which forms a junction. Power applied to this junction excites the electrons in the electron-rich material, leading to photon emission and the creation of light. Compared to incandescent and HID counterparts, LEDs provide increased light control, instant-on capabilities, reduction in maintenance costs, as well as energy efficiency. In summary, light is produced by a luminaire. Each luminaire produces, controls, and distributes light. Light control utilizes multiple refraction and reflective methods to control the candela output that is measured by foot candles and lumens. Each type of lamp will provide a determined expectancy of life, required voltage, and total wattage output. The color temperature of lamps are measured with two key factors, color temperature and color rendering index. The four predominant lamp sources are incandescent, fluorescent, HID, and LED technology. Nevertheless, Cooper Industries has a breadth of lighting products to meet any residential, commercial, light industrial, and hazardous location environments.